Hey everyone, and welcome back to the channel. Today, we're diving into a story that's not just making waves across the cybersecurity community, but should genuinely alarm anyone who uses a computer, which, let's be honest, is pretty much all of us. This isn't just another bug. It's a profound systemic flaw that has been quietly lurking within the very core of virtually every Linux distribution for 15 years. We're talking about a vulnerability dubbed GhostLock, a stack-UAF exploit that, for a decade and a half, has opened the door to serious system compromise. This top story from Hacker News has sent shivers down the spine of many. And for good reason. Let's unpack what GhostLock is, why it's been so elusive, and what it means for the digital world. First, let's get into the technical jargon a little bit, but I promise to keep it understandable. GhostLock is a stack-UAF vulnerability. UAF stands for use after free. Imagine you're in a library, and you check out a book. You're allowed to use it. But what if the librarian mistakenly marks the book as returned and puts it back on the shelf? While you're still reading it, someone else could check it out, and suddenly, you're both trying to use the same book, leading to confusion, data mix-ups, or even malicious tampering if one of you has ill intent. In the world of computers, freeing memory means telling the system that a certain block of memory is no longer in use and can be reused by other parts of the program. A use after free bug occurs when a program tries to access or use that memory after it has been freed. The memory might have already been reallocated to something else, leading to unpredictable behavior, crashes, or, in the worst case scenario, an attacker being able to inject malicious code or elevate their privileges. Now, the stack part is crucial. In computing, the stack is a fundamental data structure used to manage function calls. When a program calls a function, information about that call, like local variables and the return address, is pushed onto the stack. When the function finishes, this information is popped off. GhostLock's brilliance, or rather its insidious nature, lies in how it manipulates this stack memory. By carefully timing operations and exploiting race conditions related to how weighted system calls interact with pt race system calls. An attacker can trick the Linux kernel into thinking a specific piece of stack memory is free when it's actually still in use. This creates a window of opportunity for an attacker to write arbitrary data into that supposedly free, but still active, memory location. This means they can corrupt data, crash the system, or, most alarmingly, execute arbitrary code with elevated privileges, potentially gaining full control over your Linux machine. The sheer longevity of this vulnerability is what truly sets it apart. 15 years. Think about that. For a decade and a half. This bug has been present in all Linux distributions. From the widely used Ubuntu and Fedora to Debian, Arch Linux, and countless others, it has quietly coexisted with every security patch, every kernel update, every new feature released for the world's most popular open-source operating system. Finding such a deep-seated bug is like finding a needle in a haystack. But the haystack is the entire digital library of the Linux kernel. A codebase with millions upon millions of lines of code. It speaks volumes about the complexity of modern operating systems and the subtle ways that vulnerabilities can hide in plain sight, even with thousands of eyes scrutinizing the code. The implications of GhostLock are profound. Imagine an attacker who has limited access to your system, perhaps through a phishing email or a compromised web application. With GhostLock, they could escalate their privileges from a regular user to a root user, effectively becoming the administrator of your machine. This opens the door to total system compromise, installing malware, stealing sensitive data, modifying system configurations, or even turning your machine into part of a botnet. Servers running Linux, which power the vast majority of the internet, are particularly at risk. Cloud computing infrastructure, web servers, databases, if it runs Linux, it could be vulnerable. This isn't just about individual users. It's about the backbone of the internet. The discovery of GhostLock was made by a team of dedicated security researchers from the National University of Singapore, who published their findings and responsibly disclosed the vulnerability. Their meticulous work involved a deep dive into the Linux kernel's intricate memory management and process interaction mechanisms. It's a testament to the ongoing importance of academic and independent security research in strengthening the digital foundations we all rely on. The Linux kernel developers, once notified, acted swiftly to develop and release patches. This rapid response is one of the strengths of the open source community. Transparency and collaborative problem solving. So, what does this mean for you, the user? The most critical takeaway is: update your Linux systems immediately. Kernel updates containing the fix for GhostLock have already been released. If you're running Ubuntu, Fedora, Debian, or any other Linux distribution, check for available system updates and apply them as soon as possible. This isn't a vulnerability you want to leave unpatched. Beyond immediate patching, GhostLock serves as a powerful reminder of the continuous arms race in cybersecurity. No software, no matter how robust or widely scrutinized, is ever truly immune to deeply hidden flaws. It underscores the need for constant vigilance, robust security practices, and a healthy skepticism towards the notion of perfect security. The story of GhostLock isn't just about a technical bug. It's a narrative about the human element in cybersecurity. It's about brilliant researchers dedicating countless hours to uncover weaknesses. And it's about dedicated developers working tirelessly to fix them. It highlights the inherent complexity of software and the challenge of writing perfect code, especially in a system as vast and interconnected as the Linux kernel. This particular stack-UAF